That's not okay.
This entire chapter is devoted to solving equations. We're finding zeros, right? So we are going through all the more difficult. You've done linear, obviously, chapter 1, but now we're on quadratics and polynomials, which we've been hitting hard with factoring and all those things. Now we're moving to rational equations. Okay? And tomorrow will be the radicals, or square roots. So lots of solving equations here. That's what this chapter is all about. Very big deal. You remember what a rational equation is? What's the parent function?
That's a or 1 over x, isn't it?
Yep. Okay, that's a rational equation. Okay. The big deal here is we're going to have a lot of fractions, right? So that means we have to do fraction math.
Yay!
So, quick reminder from 5th grade. Can you find a common denominator?
12.
12.
Yeah. Why?
You multiply
Because it's the greatest number.
Right?
least common multiple.
Yeah.
So 4/12 and 3/12, right?
Yeah.
Okay, you have to be able to do that with algebraic information now. X's. Okay, that's the big part of today, is being able to take those and make common denominators with some letters in it. Not a big deal. It's a big deal, but it's not difficult. So keep that in the corner of your mind. We can start pretty simple with rational equations. And solve stuff like this. Where there is not necessarily some nasty fraction math to do, okay? But the variable is in the bottom, so how do I move this out of the bottom? This is division, right? How do I undo division?
Multiply.
Yeah, you multiply. So we're going to multiply that whole denominator on both sides. Okay. Now we've canceled these out, right? And it becomes a linear equation at this point. Okay. So getting past the rational part usually gives you a quadratic or linear or something of that nature that you have to use the tools you already have. Here we will distribute with the hippity-hoppity property. You bet. Hip hop, you don't stop. What's 33 times 45?
A big number.
More than 20, so I don't know.
And you can solve that linear equation, right?
Yeah.
What?
1,004.
1,000 what?
485.
Yeah, what,
D
that's going to be over 2,000.
He's talking with D.
D equals duh?
Yeah.
How is that 1,000?
No.
He's saying that it should be 45D minus 1,485.
Oh,
Yeah,
485. Why didn't you say that before?
that's what I was saying.
I heard 11. Not that my hearing's bad or anything. Yeah, I know it is. Trust me. I have listened to too much loud music in my day, and I run a wood shop. Bad combination. All right, what's the answer?
70.73.
Okay, there you go. So those are about the easiest you'll encounter. If the variable's on the bottom, multiply it out, solve the equation that you have. Okay? Rational equation. let's get a little bit. Okay, solve this monster.
Oh, yeah.
Oh, that's not. Here's another rational equation you might run into.
That looks beautiful.
Oh, it's very elegant. Just have some fractions to deal with. So we have subtraction here. What do we need to do?
Find a common denominator.
Yeah, you do.
Common denominator.
The nice thing about this one is we've kind of set you up for it. Can you factor this?
Oh, yeah.
Yeah, it's x minus 4 and x plus 1, right? Noticing, no, it's not, because I'm going to change my sign. Here's your sign. Okay, thank you. They match, right? Thankfully they match. Makes things a lot easier.
Oh, wow.
So what do I need to put in this denominator to match that one?
X minus 1.
Okay, and we do it top and bottom, right?
Yeah.
Common denominators. So we're multiplying by x minus 1, top and bottom, to make those match. What about this one? Yeah. And they match now, right? Okay, does anybody not know what I just did? It's okay to admit. Okay. All right. So here's the nice thing about finding your common denominators right away. We can drop the denominators now. Okay, because what we have is x minus 1 times x if the denominators are the same,
They cancel out.
yeah, basically.
So you can you
So
take
the denominator is the same, so all we have to worry about is the tops being the same, right? So all we're solving in this case is that right there. Okay. So you make your common denominator and you can drop it. Good? Yeah, it is good because it makes it a lot easier. And now we solve the equation. X squared minus x minus 2x plus 4.
Plus minus 8.
8.
Minus
You can't
Plus a
add
negative
the-
8.
8. Okay.
I'm on it today.
Can you not add the x, the negative x and the negative?
Yeah.
Yeah.
X squared minus 3x. We want it to be equal to 0, so subtract the 20, right?
Minus plus 14. Plus 12.
Wait, if you
I think I'm
have
right
positive
this
eight
time.
and
Yeah, you're right this time.
Negative 8 minus 20.
then- but that's a con- I thought that's a con-
It's negative because
Minus 0 is negative.
I wrote plus negative, kind of. Okay, fine. Quit trying to be like you guys. How's that? Better?
Eat
Okay.
a Snickers and
Huh?
Eat a Snickers.
Not you.
Eat a Snickers. I'm not hungry. If I needed a Snickers, I might be beating you up right now.
I wish you were.
Can I factor? X minus 7, x plus 4. What are my zeros? Negative 4 and 7. Oh, hold the phone. Okay, you think those are your answers?
But then,
You have to check your answers.
and if they don't work, then you just do it.
One of them may not work.
So one
Yeah, because, so with rationals and radicals tomorrow, you have to check your answer because it may not give you a right answer. Because of the way we eliminated the denominator, some funny things can happen. Okay, so we have to plug that into our original, each of them. Does anybody know what the answer to this one is already? I can tell you right now there's no solutions. Not a solution. Why?
Because
Zero in the denominator? Okay. So -4 is not a solution. Okay. Check 7, I bet you $10 that it works, but still need to do it. 7 squared plus 3 times 7 minus 4. Holy cow, that's ugly. Oh, that makes it easier. Yeah. So get your common denominator here. We get 42 over 66 minus 14. That's not right. Times 11, 22. Is that right? Yep, that works. So 22. 22.
Wait, how is it 66? Because that's bigger than 20. But that's your least common.
Check. Yeah, so times 6 here and times 11 here.
But if you do all of the stuff equals, all of the stuff on in the denominator of 20 is 58.
This is already 66. I'm sorry, don't know where you're headed.
49 plus 21 is 70, minus 4 is 66.
Okay. All right, so check your answers. Okay. So those are about the hardest ones I'm going to expect you to do. Okay. Okay, so yeah, you have common denominator. When you solve it, you end up with a quadratic, and you have to solve a quadratic. That's pretty common.
So you're only going to have one answer.
Um,
or we have to-
They could both work, but it is not uncommon for this to not, for both of them not to work. Let me give you, let's say, good example. Okay. This is a very common one that pops up in calculus. So I just want you to be ready for it. Just be able to see it. Okay. Can I factor that? Okay. Are you tempted to create a common denominator at this point?
No.
You can, if you want to. But you don't need to. Okay. What's your first thought? Can't hear you mumbling.
multiply x.
Could we multiply by x on both sides?
Yes, sir.
You can, actually. So that's one option. And you get 2x squared minus 5 equals 0 still, right?
Yeah.
Okay. Legitimate, perfectly legitimate. And you can solve that. The other option, this is what I do most of the time, is 2x equals 5 over x. So add the 5 over x, correct, to both sides? And now multiply by x. You get 2x squared equals 5, and you can solve it from there. Same problem, right?
Okay, so how do we get to the, oh, we multiply by x on the
Yeah, because it can't. So here okay, so let me,
I'm just confused on how you got from.
How many kids do you have in class?
Yeah, you're there.
I added 5 over x.
Oh. Instead of.
So those cancel out.
Yeah.
So different methods,
Oh.
okay? Different methods. Do you want to see another one of those?
No.
Yes.
No, thank you. We're good.
Many of you, yes? Okay. If you think you're ready to start working, the homework's on Google Classroom. If you want to pay attention here, I will do another one.
Can I go get my combo thing?
No.
Oh, okay.
Yeah, so here's another one that's a little bit nasty.
Why'd you do that? Why does that have to be numerator?
It's the same solution technique as the other one.
A plus 1 and A plus 1.
It doesn't matter.
But we used to plug it into the denominator, or you plug it into the numerator?
All right, so
This like adds a combination. Never mind.
what's the common denominator here?
A.
Do you recognize this?
A plus 1.
It's the difference of 2 squares, right? So what's our common denominator going to be?
A minus 1.
A minus 1 and A plus 1. So I need to right there, yeah? And I need both of them over here. Okay. What? Okay. Okay, are you good with making that common denominator? Okay, so this one has the most, right? It has both A plus 1 and A minus 1, right?
Is that what this?
So what do I need to put here? An A minus 1. And what do I need to put here? Both of them, top and bottom. Right, so what I end up with is,
Would it be, would it be easier just or less messy if you just, for the A, for the first one, if you just multiply by A squared minus 1?
yeah, it would. Right, so there are your numerators. Your denominator's gone, right? And you just have a polynomial to solve. Are you sure about that? So we have to FOIL these out. Okay, so this is a squared minus 1, right?
Yeah.
And I can distribute this in and get a cubed minus a for this term. And then FOIL that out. Yeah. Do you know how to tackle those?
Sure.
Here's,
Cancel out the a squared.
just take the a, put it in each one, that's what I did here,
Yeah.
and then take the -1 to each one. That's what that is. Yeah, it is fun because it's a function. It's so funny. All right, never mind.
And then change it down.
So let's combine like terms. Yeah. A cubed plus a squared minus a minus 5. A cubed. Oh, those cancel. 2a minus a is minus a
And plus a,
If you, yeah, it's plus a.
plus,
minus
here's your sign.
two.
Bam.
Huh?
Okay. When you're solving polynomials, move everything to one side, right? Equals 0. So,
With the a squared cancel out.
yes, thankfully. So this equals 0. So a squared minus 2a minus 3. Is that factorable?
Wait. But I thought I canceled one. Oh, wait, no, because of it.
The cubes cancel.
But then I
Thank
thought
God
the
for that.
squared
Positive 1. Just joking. No.
Or not the squared, that is.
Right? Factored. And a is -1 or 3. And now what do you have to do? Check your answer.
Yes, sir.
Can we just mock check and just know we have to?
Just know we have.
Number.
You say what are
You mean right now? Can we not check? No, we have to? Yeah, but don't do that on your homework.
Decide one of
You
these.
can't just say,
one
well,
of
I know I
these
need
is
to
true,
check it,
one of
but I
these is
didn't.
not. I don't care.
It'd be like trying to say, yeah, I built this rocket, but I'm never going to test it.
Yeah, why not?
Like,
Yeah.
just because you don't want it to blow up in your face.
Yeah. I'd rather
Um,
not have to get it from the failure.
If you check your answers, we find out that -1 does not work,
Darn.
so A is 3.
Cool. See, we didn't have to check. We
Okay.
just had to look at the book.
And take a look at these numbers. Here's some strategic thinking on your part. If I plug -1 in, right there, what does it give you?
0.
Denominator is 0. No solution for -1. If you can say that, and I'm happy.
So
Right.
if any of the denominators become 0, then
Any
it's
of
a
them,
solution?
you know, and it matches the same thing we had here, right?
Yeah.
Okay, so that's what you're looking for.
And all you need us to say is that, that
You
one
can
is
say that -1
Wait.
creates a denominator of 0. No
So Mr.
solution.
Rose-
And then that's all.
You don't have to plug it all in.
Sure.
If I just need to know that you're thinking correctly.
Even with the other one?
The other one, you have to actually do,
Okay.
because they do have to equal each other.
So is it possible just to look at it and say that if you plug 1 into that, it gives you 0, so 0 is going to be 1 of that 0 to not answer?
If I plug -1 in here,
Well, because that's what makes it 0.
it gives you a denominator of 0.
So can you,
Which is-
can you know that and say 0 is going to be, 1 is going to be one of the zeros when it's all solved out? It's not going to be the answer.
No, 1 is not going to be a 0. It's going to create a denominator of 0, which is no solution.
But is it not a 0 there?
negative 1
Is it 0?
is a 0 of this quadratic,
Yeah.
But you have
but
to
it is
figure
not a
it out.
solution to this equation.
You have to plug it back in to make.
0 here,
Okay.
but not a solution. So you have to distinguish. Okay? All right, here you go. What, do you have something going on tonight? Meeting up with a lady friend?
Oh, yeah.
Going on a date with the wrestling mat?
Going on a date with Principal.
You gonna go